There are a few problems I'm going to skip on here that I think they're a little bit more than what I want to go into. So very possibly we can get through these notes today. We'll kind of see. Okay. And go from there. So lesson 2.6 is looking at graphs of rational functions. When we talk about rational functions, we're talking about graphing ones that are fractions. Okay. So we're going to be talking about asymptotes and places the graph doesn't exist, those type of things. So rational function is written of the form f of x over g of x, where f of x and g of x are both polynomial functions. So basically you have terms added or subtracted over terms added or subtracted. Okay? Now, in this first example, we're going to talk about finding the domain. But as we talk about finding the domain, we're going to use limit notation to do this. Okay? And so when anytime, I have to go back and look at the homework to remember for sure, but anytime that you are asked today to talk about the domain or the asymptotes, we're going to use limit notation. So we've already worked a little bit with limit notation. We're going to work even more. So as we think about the domain of this problem, what do you know? What do you know as we think about domain?
X minus 2 equals 0.
Okay. That denominator. Katie's telling me to set it equal to 0, but what's really the deal? The denominator, it can't equal 0, right? So when you solve this, if we set x minus 2 equal to 0, we're going to get x equals 2. And what that's really saying is that in this problem, x cannot equal 2. What's going to be in the graph there? When x equals 2 on the graph, what are we going to see if the graph doesn't exist there? Not a hole in this case. Heading down the right direction.
What's the
An asymptote? Which type of asymptote?
vertical?
Vertical asymptote? Is this ringing any bells?
Yes.
They're deep down, aren't they?
Very.
Okay, so setting your denominator equal to 0, if you recall, will give us a vertical asymptote. So I know that my graph does not exist at x equals 2, and I know there's a vertical asymptote at x equals 2. Okay, so that's some of the information we have. Do you guys remember what the reciprocal graph looks like?
No.
I don't know. Maybe you're on the right track. I'm not sure. But reciprocal function, it was 1 over 12. It's 1 over x. I want to say, is it the first one in the second row, maybe? I could be wrong on that.
The fact that you just remember that is wild.
But I've been teaching that same.
Let's look.
I don't know. 1.3. Yeah, 1.3. So we had those reciprocal functions.
I wrote it in here.
The fact that he can just flip through his notebook and find this.
I thought I wrote it in here. Oh, I didn't put the graph. I just put the
Oh, this is the key. This isn't the black one. Actually, I don't think these are in here. I have it right. I could have. What is that?
Reciprocal function?
Like that? Interesting.
The whoop. And the whoop. Whoop. Right? Made sound effects in here. But when there's a curve up in quadrant 1 and a curve down. Oh, wait, that's my quadrant 1, isn't it? Your quadrant 1's over here? Yeah. So curve up in quadrant 1 and curve down in quadrant 3. Okay, diagonal quadrants. Now, the fact that there's an asymptote at x equals 2, what that's going to end up doing, so while we were looking and discussing here, I drew me a set of xy axes. I know there's a vertical asymptote x equals 2. What's going to happen is normally that vertical asymptote is at the y-axis at 0. Now it's going to move right 2. And so now my graph is still going to look like the reciprocal function, but it is shifted 2 to the right. Okay? So I want you to have a picture of the graph before we go in and talking about this. And I don't have it in on here, but technically there's also a horizontal asymptote where?
0.
There's a horizontal asymptote at 0. My graph doesn't cross over the axis there. Okay. When we talk about the domain using limit notation, okay, we're going to be asking, what is my graph doing? Right here, the graph doesn't exist at 2. What is my graph doing on the left side of 2 and on the right side of 2? So as I write this, I'm going to write the limit as x approaches 2, and then I'm going to put a negative after the 2. And what that's saying is, as x approaches 2 from the left. So the limit as x approaches 2 from the left is what that's asking. And then we're also going to talk about the limit as x approaches 2 from the right. That means after the 2, I'm going to put a plus sign. Okay? That negative and plus are after the value. And what it's saying is, I use the words left and right. It's saying as we approach 2 from the negative side, as we approach 2 from the positive side. I always just say from the left, from the right. Okay? So with that in mind, as we follow this graph, as x approaches 2 on the left, so 2 is my vertical asymptote, yes? As we approach 2 from the left, so as I trace my graph from the left, where's my graph going? It's going down, yes? So what is down? How do I write that? It's going to equal negative infinity. And I'm going to put some words up here so you have that in a moment. So what about the other one? The limit as x approaches 2 from the right. So as I trace my graph from the right, where's my graph going? Up. And up is positive infinity. Okay? Now, if I put this in words, first of all, this equaling negative infinity was down. This equaling positive infinity was up. That's old news, right? And what I want you to realize is this over here says as x approaches 2 from the left. Okay? Just because I know that is new notation. This one says as x approaches 2 from the right. Okay. The difference here, gotta sneeze. Okay, look at the light here. Okay, the difference here, if I just say as x approaches 2, okay, and not from the left and the right. If I look at this graph as x approaches 2, it goes 2 different directions, doesn't it? So in that case, the limit doesn't exist because a graph going up and a graph going down at 2 means it's not going to the same place. That limit doesn't exist. But if I break it into pieces, approaching from the left, approaching from the right, we can do that, okay? So when you're asked to talk about asymptotes or domain, we're going to use this form today. Now, domain talks about x's, right? So that's the key there. Not mentioned in this problem, but I just want to talk about it. This was more vertical asymptotes, right? What do we have in the way of a horizontal asymptote? We already mentioned we have a horizontal asymptote at 0, right? So when we start talking about horizontal asymptotes, or you hear me use the phrase in behavior today, what we're looking at there is what is the graph doing as it goes off to the left and it goes off to the right. So when we write these and we start talking about this, we're going to be asking ourselves the limit as x approaches negative infinity and the limit as x approaches positive infinity. Okay, so this all has to do with the horizontal asymptote. I know I haven't used the horizontal asymptote here, but as x approaches negative infinity, so as I follow my graph off infinitely left, off towards Mr. Stanley's room, what y value are we approaching there?
0.
We're approaching that horizontal asymptote of y equals 0, aren't we? Okay. As x approaches positive infinity, so as I follow my graph infinitely right, so as I head towards Ms. Minnick's room, what y value is my graph approaching?
0.
It's approaching 0 just from the top instead of the bottom, yes? So both of these limits here are equal to 0. And that will always be true as we talk about these rational functions and horizontal asymptotes. Your horizontal ones will be x approaching negative or positive infinity, and it'll equal the horizontal asymptote. Whereas vertical asymptotes, we're approaching the vertical asymptote for left or right, and it's going to equal the positive and negative infinity. Okay? So that's kind of, I just wanted you to see the notation there before we go into actually finding asymptotes and putting this all in place here. So we already talked about this. In behavior asymptotes, that's where your horizontal asymptotes occur. Okay, so what is your graph doing as it goes off to the ends, left and right? Vertical asymptotes happen when the denominator equals 0. Old news there. Okay. We're going to find the asymptotes, but then we're going to express these answers in terms of limits again. So what do we have in the way of asymptotes here? Okay. There is a vertical asymptote. Vertical asymptote at x equals -3. Are we in agreement? Because that's where the denominator equals 0. Okay. Based on what we did up above, okay, there's my vertical asymptote. What limits am I going to write? So we're going to look at the limit as x approaches -3 from the left of f of x. And we're going to look at the limit as x approaches -3 from the right. So that's always going to be your setup for vertical asymptotes. What's my graph doing on the left of it? What's my graph doing on the right of it? Okay? Now, we haven't really talked about what this graph looks like yet. Do I want to do that now or later? Might as well do that now, I guess. Do you see how this graph is kind of similar to that graph up above? Up above is 1 over x minus 2. This is 2 over x plus 3. I'm going to just sketch a little graph over here. Vertical asymptote where? -3, yes? So, and you guys can graph these on the calculator, yes? Okay. If you graph this on the calculator, you would see it looks a lot like the last one in that on the right it's going up, and on the left it's coming from below. Okay? Now, based on that graph, how do we answer our two questions down here? The limit as x approaches -3 from the negative side of f of x. Where's my graph going? On the left it is going down at -3, isn't it? So what does that mean? Equals negative infinity. What about as x approaches negative 3 from the right? Where is it going? It's going up. So that is positive infinity. Okay. Now, the other piece we haven't talked about. Horizontal asymptotes. Do you remember any of your horizontal asymptote rules?
Well, isn't it if the greatest or if the biggest power is on the bottom? Something with that, but I don't remember why.
Has to do with powers. If the biggest power's on top, there's one answer. If the biggest power's on bottom, there's a different answer. If the powers match, there's a different answer.
Yes.
The biggest, where's our biggest power here?
Bottom.
On bottom. The biggest power is on bottom. The horizontal asymptote is always, what was it up above?
0.
0. Okay, so these are rules we have to go back and remember. What? Asymptotes would have been lesson 1.2, I think. If you're looking for the rules, I think you have to go back to 1.2. 1.2 had a lot of different stuff in it. Okay, so we're going to write the limits here. Horizontal asymptote. And actually, could you almost even tell that just by looking at the graph?
Yeah.
I mean, you can see that everything's running along the axis there, isn't it? So, with that in mind, okay, I mentioned up above, when you write horizontal asymptotes, we're going to write the limit as x approaches negative infinity. I want to know where that's going. And we're going to write the limit as x approaches positive infinity. I want to know where that's going. As my graph goes off to the left, what y value is it approaching? It's approaching that axis, yes? As my graph goes off to the right, what y value is it approaching?
0.
They're equal to each other, aren't they? These two limits will always be equal to each other. In fact, it is common to see this written as limit equals 0. I'm not saying you have to do that, but that is common to see. That those two limits will always equal each other for a horizontal asymptote. Because the graph follows along both sides. Okay? Okay. Questions on A? Okay. We're definitely going to do B. We'll see. I may or may not do C. Trying to get the basics here. So B. What do you notice about B?
Vertical asymptote at x equals 2.
Yes or no to what she said?
Yes.
Okay. Vertical asymptote at x equals 2 because that's where the denominator equals 0, right? Okay. So, what are the two limits you're going to write?
Limit as x approaches 2 from the left. Or from the left. Left.
Uh-huh.
And then limit as x approaches 2 from the right.
Okay. So, vertical asymptote, I want to know the limit as x approaches 2 from the left and the limit as x approaches 2 from the right. Oh, we don't have the graph yet. I'm like getting ready to say, okay, what are your answers? Now, this graph is a little different. Before we look at the graph, let's talk horizontal asymptotes. We'll come back and fill in these answers here in a moment. What's my horizontal asymptotes? Horizontal asymptote.
Is it at 1?
Not 1. No.
3?
You know why? Or are you just guessing?
Isn't it if both are the same, then it's the it's the leading coefficient.
Okay. Is it coming back to us? You guys are getting it. You're getting there. Okay, so this up above, bigger powers on bottom, we said y equals 0. Here my powers are the same, right? Highest power on top is x to the first. Highest power on bottom is x to the first. If your powers match, you're using the coefficients from those powers. So that means my coefficients are 3 and 1. 3 over 1 is 3. So we have a horizontal asymptote at y equals 3. Now, technically, without even graphing this, you can write your limits, and you can answer your limits on the horizontal. Okay, what was I trying to get you to realize on the horizontal? My limits are always going to be what? Limit as x approaches negative infinity, and the limit as x approaches positive infinity. We haven't looked at the graph yet, but what are these both supposed to equal?
3.
They're both supposed to equal 3. My graph is supposed to be following out along the line y equals 3. Now, you kind of have to have an idea of what the graph's doing to answer the other one. So, if you haven't graphed it, graph it. Or I'll put it up here. Now, you can use, let's see, how do I want to do this? Keep in mind, there's a vertical asymptote at 2, yes? There's a horizontal asymptote at 3. So my graph has to work around those asymptotes. I believe based on what I have in my notes, tell me if I'm wrong, it's actually in the upper left quadrant and bottom right quadrant. It has to do with we don't have just a number on top. There's a variable on top now also, the 3x minus 7 on top. Okay. It works, just being able to take that reciprocal graph and shift it works as long as it's just a number on top. When we throw the variable on top, that's when the difference happens. Okay. What do we have? 3x minus 7 over x minus 2. Now, the asymptotes aren't showing on my calculator, but can you visualize where they are? Okay, and this is where I like to always encourage you, and you guys are learning, but I like to always encourage you that, okay, if we graph it before we've looked at the equation, can I go back and now and say, oh, that's x minus 2. Yep, there's an asymptote x minus 2. Oh, there's a 3. I can see the horizontal asymptote at 3. Okay? Let's see. Were my horizontal limits correct? Yeah. They were, weren't they? Okay. We had the limit as x approaches negative and positive infinity. They're both equaling 3 because my graph on the left, it's running above 3. On the right, it's running below 3. So they're both going to run along the y value of 3. Okay. I saw some erasing. Has some of you guys already guessed and filled these in? Limit as x approaches 2 from the left. What are we doing on the left?
Positive.
As we approach 2 from the left, my graph is going up. Up is going to be positive infinity. What about as x approaches 2 from the right?
Negative.
Tracing my graph, it is going down, which is negative infinity. Okay. Let's go ahead and look at C real quick. Where am I at on time? Let's look at C, and then there's one graph that I want to make sure I get in down below. So I think I can make this happen. We'll see. C. I want to throw in C real quick because it's different. Thoughts on asymptotes?
Square root of or square root of what? Or negative one?
Square, technically, if you set the denominator equal to 0, right? Like x squared plus 1 equals 0. X squared equals negative 1. So that puts us at plus or minus the square root of negative 1, which is imaginary. Do we talk about asymptotes, imaginary asymptotes? No. So, okay. What's that mean about vertical asymptotes? Okay. So there are no vertical asymptotes. Okay. What about horizontal?
One.
Y equals 1.
No.
I don't remember what it is.
So it's the third part of the rule that we haven't done yet, right?
Yeah.
Bigger power on bottom, it's 0. Powers match, it's a coefficient. Bigger power on top, nope.
It's none.
There's no horizontal asymptotes. Now, okay, so here's the deal. There's no vertical, there's no horizontal, and that's because bigger power is on top, right? What happens, though, in this case, is when there's no horizontal asymptotes, there's actually something called a slant asymptote. When the bigger power is on top, there is a slant asymptote. And I can't remember, I don't always do this example, so this may not, well, I think slant asymptotes come up a little bit in homework, but not a bunch. Okay, I mainly focus on horizontal and vertical. Officially, to find your slant asymptote, you divide this. As in, now, we could go very official, but I'm not going to go very official due to lack of time here. Officially, to do your slant asymptote, you would do x cubed plus 8 divided by x squared plus 1. That's not official, okay? But just in general, what do you know the first term is going to be in your answer? How many times is x squared going to x cubed? Or in other words, x squared times what is x to the third?
X.
And that is x, isn't it? Okay, so your slant asymptote is going to be something along the lines of y equals x. I don't have on this one if there's a little bit more to that or not, but it's going to be something along those lines. Now, this still falls into the horizontal section. Horizontal asymptotes and slant asymptotes both fall into end behavior. So I know some of you have pulled up the graph, some have not yet, but so I'm still going to write the limit just like we did with horizontal. The limit as x approaches negative infinity of f of x, and the limit as x approaches positive infinity of f of x. What does the line y equals x look like? Okay, it's a diagonal line going through 0, 0, yes?
Yep.
That's what our graph is going to have as an asymptote, is something along those lines. X to the third plus 8 over x squared plus 1. Do you see the asymptote is running along?
Yes.
There's that diagonal asymptote. Okay. There's that diagonal asymptote that my graph is running along. Something like that. Okay. I can't do it justice. But think about these answers. As x approaches negative infinity. So negative infinity means as my graph goes to the left. So as we go farther left on the graph, where am I going? As we go left, I'm also going where?
Down.
Down. So we're going to negative infinity. As we approach positive infinity, so as my graph moves to the right, where is it going? It's going up to positive infinity. Okay? And again, I don't remember that you have a whole lot of slant asymptotes in homework, but I also felt like I should introduce them and mention them a little bit. Okay? Now, the bottom section is about graphing rational functions. We are beginners. Okay? We are beginners. I'm not looking for you at this point to be able to fully put a graph together. But I'm looking for you to be able to put the pieces together to at least get part of the way there. Okay? This is not something where I 100% want you to put the graph together and be able to tell me exactly what it looks like. But I want you to be able to put the pieces together. So down here, we're going to look at example B as our example. Okay? It's the one that has the more traditional asymptotes, which is why I want to look at it. But in order to graph rational functions, there's 4 pieces listed here. Okay? We're going to talk about in behavior asymptotes, which in behavior asymptotes can be horizontal or slant. We're going to talk about vertical asymptotes, x-intercepts, and y-intercepts. So, I'm going to call it step 1. Let's talk in behavior. As we look at example B, any thoughts on in behavior? Any horizontal asymptotes, slant asymptotes? Horizontal asymptote at y equals 0? Why?
Oh, yes.
Okay, I switched the order of what we're doing here, right? So biggest power is on bottom. So there is a horizontal asymptote at y equals 0. Okay, and if you need to write yourself a note, bigger power was on bottom, yes? Okay. Step 2.
Vertical asymptote.
Vertical asymptotes.
Is there one? Okay. -3. So it'd be +3 and -2.
Yes. Why?
Factored it.
Okay. That's denominator. Does it factor? And honestly, I should have had us factor it from the beginning. I didn't think about it. X minus 1 is x minus 1. X squared minus x minus 6 factors into x minus 3, x plus 2, right? We know that. And so if you set each of those equal to 0, you get vertical asymptotes of x equals 3 and x equals -2, correct? Okay, I'm just gathering information. We'll put it on the graph here in a moment. 3. One of my intercepts. Which one did I have? X-intercept. Now, I gave you some hints up there, but x-intercepts happen when? Not when x is 0, but...
The numerator.
Oh, okay. Numerator 0. So when y is 0. Now, the idea is when we talk about y being 0, so when this fraction equals 0, when does a fraction equal 0? When the numerator equals 0. So if I take my numerator and set it equal to 0, what's my x-intercept going to be? 1. So you're going to have an x-intercept at x equals 1, or if you want, you can think about that as the ordered pair, 1, 0. So that means 4 is y-intercept. Y-intercepts happen when
X.
x is 0. Notice y-intercept, it says what f of 0 equals. So basically, put 0 in for x. If we put 0 in for x, what am I going to get here? I'm going to get negative 6 on bottom. What do I get on top? Negative 1.
Negative 6.
Negative 1 divided by negative 6 is going to be a
Positive.
positive 1/6. Are you there? 0 minus 1 over 0 squared minus 0 minus 6. Negative 1 over negative 6, which is 1/6. Or you can think of it as the ordered pair. 0, 1/6. Okay. Now, we have all the information. Let's put it on the graph. Okay? So, horizontal asymptote. Y equals 0. Says what? Okay. It's not going to cross the y-axis as it goes off to the ends. Doesn't mean it can't cross in the middle, FYI. Okay. Vertical asymptotes at
Negative 2, 3.
Okay. So vertical asymptotes at negative 2 and 3. So right there, we know our graph does not cross vertical asymptotes. Okay, it runs up along them, runs down along them, but it does not cross them. Okay, what else do we have? X-intercept of 1, 0. So that means I'm going to cross through the x-axis at 1. And a y-intercept at 1/6. So I'm going to cross through the y-axis at 1/6. Just above 0 there. Okay. That's what all of that information gives us. Now, the other part that you guys don't really know about, all of these factors are positive up here, yes? We have positive x, positive x. When we have positives, what that tells me is that when I start my graph from the right, I'm going to start up here on the positive side of my horizontal asymptote. Okay, or my positive side of the x-axis. So I'm going to start here. Now, picture with me, what's this graph going to do as we're approaching that vertical asymptote? It's going to have to turn and go up, isn't it? So there's the first part of my graph. I think I mentioned, I'm trying to think if I mentioned this in pre-calc or calc, or algebra 2, who knows. When you hit a vertical asymptote, your sign changes. So right here, my graph was positive. Now when I change over here, my graph's going to be negative. So my graph is going to be coming from down below. Those points kind of tell me where I have to go, in that it tells me I have to cross through the x-axis once. It tells me I'm crossing through the y-axis right here. Does it ever tell me to cross back through the x-axis? No. So what that's telling me then is I'm going to go up here, curve through those, and go up along the next vertical asymptote. And then vertical asymptote. My sign changes, so now my graph is going to start below again, and this time I'm going to run up and along the horizontal asymptote. My graph looks something like that. Now, this, when I actually drew the graph, did I expect you to understand, be familiar with 100% all of that? No. Okay? That's part of our learning process here. I'm not going to take away your calculator and say, okay, I need you to draw this with just this information. We're not quite there yet. Okay? We're working to get there, but we're not there yet. But I want you to be able to find this information, and I want you to be able to put it together with what the graph looks like. Okay? So, what I want you to do, A and B have slant asymptotes. I can't remember how much you run into those in homework. I want you to go through and do the homework. I'm not going to necessarily come back and do the other A and C. Okay? So do the homework. We'll talk about it tomorrow. My hope is to have time to start 2.7 tomorrow. I don't remember how these questions go. Remember, let's see, what's today? Today is Wednesday, right?
Yes.
Tomorrow is Thursday. Remember, Friday, I'm not planning to teach in here because
It'll be 10 o'clock.
a bunch of you are going to be gone, aren't you?
Yeah.
A bunch of you are group 1, and will come back right at the end of class. I think most of you, with the exception of maybe my juniors. Are you guys group 2?
I'm group 2.
Yeah, you guys are second farther in the alphabet, so.